Okay, I'm going to show you in a minute. We're going to move on to trig functions, but let me just remind you of the rule we're going to be using. We're going to be using the chain rule here. So in the chain rule, we're actually going to see some trig functions where instead of sine of x, we're going to have sine of u, where u is some function of x. And we're going to find that in order to find the derivative of those, we'll take the derivative of the function with respect to u, and then we'll multiply by the derivative of u. And in this case, u will be whatever the argument of the trig function is. So if we apply that chain rule to the 6 trig functions, we'll actually get these 6 formulas. And remember, every time I say u, u is not x. U is actually some function of x, like x squared or square root of x. So here, if we want to take the derivative of sine of some function of x, then that would be the cosine of that same function, and then multiplied by the derivative of that function. And likewise, if we wanted the derivative of cosine of some function of x, that would be minus the sine of that function times the derivative of that function. And then the rest of the rules pretty much follow like they did in the simple trig rules, but we apply the chain rule. So the derivative of tangent u would be secant squared u times u prime. The derivative of secant u would be secant u times tangent u times u prime. The derivative of cosecant u would be minus cosecant u times cotangent u times u prime. And then the derivative of cotangent u would be minus cosecant squared u times u prime. So let me just show you a few of these examples here. So in this example, we have sine of x cubed. Now what you need to understand here is how this relates to the rules that I just gave you. So this can be thought of as y equals sine of u, where u is x cubed. And then if you go back and look at the rule for that, the derivative of sine u is cosine u times u prime. So we would just copy down this, but with cosine. So we'd have cosine of x cubed, and then we would multiply by the derivative of u. And again, you could skip this step, but I'm just showing you what I'm going to do. I'm going to take the derivative of x cubed. Now, we know the derivative of x cubed is 3x squared. So my final answer would simply be 3x squared times cosine of x cubed. Now, the next one, I went ahead and used a different independent variable using theta here. But for this one, I want to find the derivative of theta, 3 theta, minus tangent of 2 theta squared. I didn't have theta on my keyboard, so I just went ahead and wrote this as 2t squared, but just let t be theta. So the u is actually the 2 theta squared that's in here. So that's actually what we've got there, is that we have tangent of u here, where u is 2 theta squared. So we take the derivative of this just like we did for many others, and so we have 3 theta minus tangent of 2 theta squared. So when we take the derivative of 3 theta, that's just going to be the constant 3. And then if you go back and look at the derivative for tangent u, the derivative of tangent u, remember, is secant squared u times u prime. So just for this second term, we would have minus, and then when we take the derivative of tangent 2 theta squared, we would get the secant squared of 2 theta squared. But then we have to multiply here by the derivative of 2 theta squared. And the derivative of 2 theta squared is just going to be 4 theta. So we're going to bring the 3 down, and then I'm just going to put the 4 theta in front of the secant squared, and so we'll get 3 minus 4 theta times secant squared of 2 theta squared. So in the next one, we're going to have to apply this rule to each of these terms. So the first term is secant of 5x. So in that one, we're going to think of u as being 5x. And the next one, we have cosine of x squared. So u would be x squared. Now on this one, I went ahead and just did this in my head. So let's see if we can do this in our head here. So what's the derivative of secant u? Go up here, the derivative of secant u is secant u tangent u times u prime. Well, then that would mean that the derivative of secant 5x is going to be secant of 5x. It's going to equal secant of 5x times tangent of 5x, and then times the derivative of 5x, and that's where the 5 comes from. The derivative of 5x is 5. And then for the cosine of x squared, remember what's the derivative of cosine of u? The derivative of cosine of u is minus sine u times u prime. So when we take the derivative of cosine of x squared, we actually get minus sine of x squared. And since this had a minus in front of it, a minus is going to be plus. So it gives us plus sine of x squared. But then after I do the sine of x squared, remember I have to multiply it by the derivative of x squared, which is 2x. And so there's some simple examples of these basic trig rules when you're finding the trig of an argument other than just the independent variable. Okay, what I'm going to do in the next video is I'm going to apply these trig rules, but they're going to be nested in to where you have to do some other rules like the general power rule or product and quotient rule. So we'll see these in the next video.